All right, everybody. So this is the wetland types. We're going to talk about a bunch of different types of wetlands. Now, one thing that I actually really hate is these type of lectures that go through and talk about this is, habitat A and it has these characteristics. This is habitat B and it has these characteristics. All those type of lectures are just really boring and really hard to figure out, what's going on. So we're going to do something a little bit different. So here's a scenario for you. Dr. O'Neill is lecturing on why students should cheer for the Minnesota Vikings. His main learning objectives are to make students realize that all science points to the fact that the Packers suck and the Vikings are better in every way. Halfway through his class, he falls over dead due to the excitement of his favorite topic. Now, as a class, you decide that you will need to hide the body to avoid suspicion. Other people in the biology department know about the lecture and you don't want to be blamed for killing a Vikings fan. You realize that the police will investigate this further. Since you don't have the time to be interrogated during finals week, you hide the body. So what we're going to talk about is, be thinking about today is, in what type of wetland would you want to hide my body, my festering corpse, right? So there's all sorts of different factors, and there's good wetlands that would hide my body well, bad wetlands that wouldn't hide my body well, and you're going to have to figure out what that is. So the priority is to never get caught. All right, so you can use the information learned in these lectures, or in this lecture, I should say, to inform your decision. Okay, and the assignment is a 300-word essay detailing why you put my corpse and where you put it. Like, tell me why you decided where to put it. There's lots of factors you can consider, and there's not necessarily a right answer, but there certainly probably are some wrong answers. All right, let's get started.
Now, when we talk about different wetlands, we need to realize that the terminology is oftentimes very confused depending on where you're from. Different people call different things, have different naming systems, and they might not mean necessarily different habitats. Wetlands are all over the world, and I might not be using the same terminology that you know. But what terminology I will be using, I'm going to be talking about non-tidal freshwater wetlands, right? So freshwater and non-tidally driven, so not along the coasts. We can basically divide this into 4 different areas: marshes, northern peatlands, southern deepwater swamps, and riparian wetlands. So let's go through those. So marshes. Okay, are you going to hide my body in a marsh? There are many different types of marshes, right? What we generally see is most marshes always have water. They're characteristically determined by emergent soft stem vegetation, so you're not going to find trees in them. And realistically, you mostly find poorly drained depressions. So what we see is the master variable, and you can pretty much say this to almost any wetland. The master variable, what drives a wetland ecology the most, is its hydrology, which is controlled by precipitation and then evapotranspiration. Marshes generally have a higher pH. That neutral to high pH releases a lot of nutrients, making it high productivity but also high decomposition. So you don't really get that much peat accumulation. If you do, it's really low, but peat is just when you have higher production than decomposition. If you can continuously have higher production than decomposition, you get an increase in our dead organic matter over time. And realistically, marshes don't really have that much of that. The turbidity then, how cloudy the water is generally determined on what type of animals are using the water, and what we see is generally clear water. We'll talk about that later on here in a second. For the vegetation, usually we can, within what type of marsh is determined by what type of vegetation you have. One very common thing is you have floating mats. So in the roots of these plants are a lot of really gas pockets that we talked about last lecture a little bit, that can make the plants extremely buoyant. The roots then can grow, get bigger, and eventually, so things like typha, cattails, and sedges can break off from the shoreline and create these floating mats of vegetation that are pretty interesting. And they just float around the wetland or crash into the sides, and eventually could become, move around to the other side of the lake or the wetland. Now, prairie potholes are this type of wetland that we kind of see in northern Minnesota over to North Dakota, South Dakota, and Montana. And they have this really interesting 5 to 20 year cycle depending on the hydrology of the system. So think about a dry marsh. What happens is the buried seeds, the seeds in the sediments, will germinate because they've hit that dry period, and you'll get a lot of really annuals and perennials. When the water comes back then, so we're northern type of area, so we might get a snow melt or something where inundated over any amount of time, only the perennials are left because the annuals complete their life cycle and go away, and the seeds don't regenerate or don't germinate. They just sit there waiting for another dry spell to come. So we see emergent plants dominate. Now, realistically, what we're talking about is a lot of cattails, a lot of reeds. When you get a lot of those cattails and reeds, this is a really common food for muskrats that will come in and eat all of these plants. And we'll go through what we call this degeneration phase. The muskrats eat up these plants, and what you get then is this like open lake that you'll get a big influx of muskrats, but then, during this lake phase, you'll still have some muskrats, but not that many. And then it kind of sits in this open water phase until you hit a dry spell, and then it goes back to the dry marsh. So think about, is this enough time for my body to decompose? Potentially, maybe not. All right. Marshes, they'll have lots of different types. You might just have a wet meadow, which is a little area that, just kind of gets squishy, soggy ground that's saturated with sediment or water that might not really ever be inundated completely. But then you might have, typha cattail swamps like you have here, or, this is another type of meadow or of marsh. Northern peatlands, then. These are areas where traditionally we would call bogs or fens, but they're not necessarily only found in the north. You could find them in high altitude, in maybe South America, but at extremely high altitude. So what we see is there's low pH, the low nutrients, and low minerals in the water. Right, because that low pH binds up a lot of the nutrients and they're not allowed to get out. So we'll talk about why sphagnum moss makes acidity. We'll talk about that in a second, but you have really a lot of number of endemic species here. Generally what we see is, a whole bunch of northern Minnesota will be peatlands. Some portion of the UP of Michigan and Wisconsin will have them, but realistically, most of the stuff we're talking about is in Canada. So sphagnum moss is this really interesting plant that is really good at holding water. It can hold 15 to 23 times its weight in water, and it's what we call a foundation species. It has it creates a positive feedback loop. So sphagnum moss creates acidic water. The more the acidity, the more acidic the water is, the better the sphagnum moss. So the sphagnum moss creates the acidity, but the acidity allows the plant to grow better, so it just makes it more acidic and more acidic and more acidic. So peatlands have really low temperature, right? We're talking about northern Wisconsin, northern Minnesota, up into Canada. They have low temperature, they are acidic, and that means low decomposition, right? You don't have a lot of nutrients, so you have little bacteria. The acidity limits the bacteria. The temperature limits the bacteria. Everything is limiting the bacteria. Also, you have really low diversity. Not too many plants can live in this really acidic environment, in this low nutrient environment. So the plants that do live there are relatively rare, and you only find them there because these are very specific conditions. We see a lot of carnivory in the plants. Pitcher plants, sundews are really, really common in northern Wisconsin, so they're going to be needing to get those nutrients from the insects that fall into their little pitcher plants, or they get caught by them, right? So a lot of sphagnum moss is really common here. Tamarack trees, cranberries, the cranberry bogs that you think of, and water shield. Water shield is one of my favorite plants. It looks like a lily pad covered in goo. But what you see is because we're low temperature up north, precipitation exceeds evapotranspiration. So basically you have water available year round, and production is much, much higher than decomposition. Now this is somewhat temperature dependent. It's really hard to get a bog down here, even like down here in southern Wisconsin. There are some bogs around, but they're not going to create as much peat as a much more northern bog is up in northern Minnesota and into Canada. So oftentimes the sphagnum moss can grow above the water table and keep water. The water is only going to be from precipitation, never from the groundwater. So you can actually have like a bog perched above the water table, and it has very little nutrients then. This is sometimes what's called a quaking bog. And lakes themselves can go from an open water lake. So if you have a lake here, but then at the edge of it, you'll create, as sphagnum moss takes a hold, it can grow over the top and create this underground, basically, lake until it fills up with all of the peat from the sphagnum moss that is floating up above the water. There's a cool video. I'll link to it in the description. You can also have bogs being created from a terrestrial system. So it just takes a little depression or just an area where you get sphagnum moss taking a hold that can grow up, and since it doesn't decompose, it makes this like mound. I mean, this is miles and miles wide, right? So this mound of sphagnum moss, and since it holds so much water, it's acting as a wetland. And these mounds and mounds and mounds can, over time, get turned into peat, and this is what these Scottish people are doing. They're mining peat from their bogs, their old bogs that are no longer wet anymore. But this is what is in your potting soil that you buy at your greenhouse to grow your plants. Because the reason why we use peat is because it's that old sphagnum moss that can really hold onto the water really well. So it's really interesting because of that little decomposition. We have found bodies buried in the peatlands of this person seemed to end in a not so nice death, but they're not found for a long time, but there's always evidence and shown what the person might have actually even looked like. Pretty interesting stories of, I have a book called Bog Bodies that is pretty cool. I don't know if that's a good place though, because the evidence will be certainly preserved in that low decomposition area. But that's up for you to decide if you want to put me in a peatland or not. So, what about southern deepwater swamps? Is this a good place to put my body? Swamps are oftentimes defined as forested wetlands, right? So in we're talking about southern U.S. here. We're thinking about cypress, black gum, and tupelo trees. These are relatively permanent waters, so the water can fluctuate, but we're really talking about a lot of water all year round. The chemistry of the water, though, is really dependent on the subtype of where the water is coming from, whether it's precipitation or groundwater, and how connected it is to a river. And we'll see a lot of these southern deepwater swamps are coming from river water. So where do we find this? This is the Cypress distribution, and if you were to put black gum and tupelo trees, it'd pretty much map right on this. But here, but basically above these lines, it's just too cold for the trees, and they don't do very well. So when we think about the different subtypes of these swamps, let's first talk about Cypress Dome. It's a small, permanently inundated, isolated depression. So what does that mean? You've got a big land here, and then there used to be a depression here where that filled up with water, and then those trees took hold. Okay. The thing is, these are disconnected from the groundwater. They'll have that tea-colored water that's really it's the same kind of water that you would have in like a bog or a peatland, and it would be that high organic acids, high humic acids, so you would have low decomposition in this area. A dwarf cypress swamp would be basically the Everglades, okay, where you have a big area of limestone. So that limestone is very porous, so water quickly can go drain off of there. If the rains stop, it can get very dry there, and we get because of this underlaying limestone, the trees don't get very tall, and they can get very dry, and you get fire that can sweep through this system relatively easily. There's also going to be alligators here, so this might be a good place, but the fire will could come through and expose my body relatively easily, right? So think about that. What about a lake edge swamp? Is this a good place to put my body? The southern, basically any lake you have around down south will be surrounded by these big trees, these cypress trees. And the water will be fluctuating quite a bit in these systems because most of these lakes will be at least highly river driven. So you get a lot of water movement in the lake and in the river, and but they're really good for filtering upland nutrient runoff. Cypress strands, then, you can basically think of these as like little areas of along a river valley that get flooded. They're relatively slow flowing, where the stream doesn't have really much power, but you're going to get really fluctuating water levels due to the just average wet-dry cycle of the year and how much water is flowing down the stream or not. Alluvial swamps, these would be found in bigger permanently flooded depressions on floodplains, so bigger rivers, so oxbows, sloughs paralleling the rivers, or just the floodplain of any bigger river. So pretty much any southeastern river will have this along, and water will flow in and out between these trees, creating the biggest cypress trees because they're the most permanent water systems that you'll have that is needed for these cypress trees. But there's going to be a lot of water flow, so maybe not the best place for my body. For the next type of wetland I want to talk about are riparian wetlands. Now these are extremely not well defined. It's basically, think about the area along a shoreline of a river, and there's just a huge variety of types, and it's kind of just based on the river type and also the plant species that you find there. These are also some of the most endangered habitats because of river channelization in the U.S. continues to happen, put levees to protect areas that were trying to not have flood. But as soon as we put up a levee, we're completely eliminate these riparian wetlands. Now, because a general river, a natural river, will have some sort of floodplain that is relatively close to the ordinary high water level. There'll be a high water table in here. The water will be very close to it, so it's oftentimes saturated soil. And this is, think about right along the river in a meandering river or an oxbow will create these wetlands, or like older oxbows will be turning into these type of wetlands. And oftentimes when we think about this, we can model it using the flood pulse concept, right? Because that flood pulse concept, remember, was looking at the aquatic terrestrial transition zone, so that area right along the floodplain, right at where the river is, and how those determine the ecology of the whole river. So what do the floods do? They provide water. They provide a whole lot of nutrients. The flow of the water can force oxygen into the sediments. It can also carry away waste and dead organic material. So these are generally what we think of as really open systems, where material will be flowing in and flowing out. In a longitudinal context, because you have a river flowing downstream, bringing nutrients from upstream down into the wetland. The wetland can trap those sediments and nutrients, but also export them. And we also have sediment or nutrients going in and coming out. So if you have like 50 meters of riparian forest, most of the nitrogen that gets put into the river, most of the phosphorus that gets put into the river will be taken up by that riparian forest before it even gets into the river. So when we're getting rid of these systems at really high rates, it's really concerning. Because why do we want to get rid of it? Well, maybe you want to put a restaurant along the river, right? So this river here is going to be not natural in the slightest, right? So developing for city use, for agricultural use. Oftentimes farmers will really want to say, I want to farm this land and it's too wet, so let's drain this riparian wetland so that I can farm it. But then you're just kind of getting rid of all of your alluvial nutrients that are coming in, and it can really cause problems for the surrounding area that the river isn't allowed to flood anymore, let alone for the organisms that are living in there. Then as soon as you dam a river, it's limiting the water fluctuation, so it's not going to be able to, you won't get that flood pulse that will then continually replenish the water table in that area.
So, where do you want to hide my corpse? Some things to consider are geographic location, decomposition rates, covering over with vegetation, all sorts of types of visibility, and then how the water is flowing and whether it has water or not. The grade for this assignment will kind of pretty much be based on how comprehensive you cover all the different factors that I just mentioned there and all the different factors that we talked about kind of throughout the lecture. All right. Good luck, and I hope you don't get caught.